Hello students and welcome back to the next session of array and matrix in MATLAB. Let us understand the indices of matrix in MATLAB where it starts from 1 and not 0 like in C. So here the indices starts from 1, 2, 3, 4, 5, 6, 7, 8 and 9 for 3 by 3 matrix. Let us understand it with a small example. Let's consider a matrix A with these contents. So now what will be A of 6? So considering this as matrix and indices as 1, 2, 3, 4, 5 and 6, and so A of 6 will be 7. Similarly, A of 3 by 2, meaning the matrix of third row and second column. So let's say this is our third row and second column, and so the answer is 7. Now here A in the bracket 2 comma just a colon is given, which says that second row, and what about this column specifies that it's a complete column is given, because after the colon nothing is given there, and so second we have our second row and it is complete. So 6, 8 and 2. Now here in the indices it writes A into the bracket 1 colon 2 comma 2. This specifies as first and second row and second column. So you have first and second row of second column, which says that it is 5 and 8. A of minus 2, A of 0, these are subscripts indices which must be either real positive integers or logicals. Even indices exceeds matrix dimensions. So make a point over here. Now concatenation of matrices. Let's consider the matrix of x, y and z with respectively 1, 2, 4, 5 and 0, 0. When we write down A is equal to x, y, the output or the answer what we get will be the concatenation of x, that is 1, 2, 4, 5 together. Similarly, if we write down B equals to x colon y, here the colon is separating the two matrix in rows and columns. We are representing it as 1, 2 and 4, 5. Please make a note of the errors. Now let's learn few operators, that is arithmetic operators with matrices in MATLAB, where we can have the operations as addition, subtraction, multiplication, division, the power and the complex transpose. Let us first consider the two matrices, which is A, which is defined as 1, 2, 3, colon, that is semicolon, 4, 5, 6, semicolon, 7, 8 and 9, which will be represented as the answer with the matrix 3 by 3. If you have an error while giving the notation or of a matrix, if you forget one number, MATLAB will definitely give you an error. So here we have the complete matrix, say A, and this as B. So let's add the two matrices. First, before going into any operations, please try to solve it on paper and then see the output. So here in MATLAB, we will be adding two matrices A and B, where we say that a new matrix has to be generated with A plus B. And so you have 1 plus 3, which is 4, 2 plus 5, which is 7, 3 plus 2, which is 5, and so on till 9 plus 9, which gives you 18. Similarly, we can move on with the different operations. Let's see for the operation of subtraction, where y, a new matrix is generated with A minus B. So your A minus B, and so 1 minus 3 will give you minus 2. Similarly, 5 minus 2 will definitely give you 3, and 9 minus 9 will give you 0, and so on. You can check for the other. Now, for product of any two matrices, we follow row into column the addition, that is 1 into 3 plus 2 into 5 plus 3 into 3. The total is 22, which forms over here. Similarly, go on and solve it and check for the same products. So this complete operation is just done by this signs in MATLAB. To get a transpose of any matrix, I have to specify as T is equal to A and asterisk, which is transpose. So I am finding here, I'm telling MATLAB to find the transpose of A matrix. If I would have written it as B, it would have found the transpose of the B matrix. Currently, we are finding it for A. And so you have the rows converted to columns, which is nothing but the transpose of the complete matrix A. Let's learn few more operators in MATLAB for element by element. That is, you have a multiplication sign with a dot. So dot multiplication, which is element by element multiplication, dot division, and dot power. All these specify it is element by element division and element by element power respectively. Now here, let's consider a matrix A, which is 1, 2, 3, 5, 1, 4, 3, 2, and minus 1, which is in 3 by 3 matrix, 3 rows and 3 columns. Now, if I specify here as x is equal to A in the bracket 1, comma, colon, specifies that first row and how many columns? It specifies all the columns, because it's not specified here which particular column is to be printed. And so your x becomes 1, 2, and 3. First row, all columns 1, 2, and 3. Similarly, for y is equal to A of 3, comma, colon, means what? Third row, complete column till the last column. So you have 1, 2, and third row, and so you have it as 3, 2, and minus 1 as your y. Now we are going to have an element to element operation for B matrix. We specify as B is equal to x dot multiply for y. So what do we get now is this multiplication will be matrix element to element. That is 1 into 3 gives me 3. 2 into 2 gives me 4. 3 into -1 gives me -3. So this is an multiplication element by element operation. Similar ways, division of element by element respective to x and y. So this x and this y we get C as 0.3333, 1.0000 and minus 3.0000. Just there's a small mistake. You can consider it as been written here itself. It won't come to the next line. Now let's consider the element to element operation for power. Okay, so here we have, let's say, the same matrix A, X and Y. Now if I say D is equal to A dot power 2, now here I am making square of all the elements which are in A, which says that 1 ka square 1, 2 square is 4, 3 square 9, 4 square 16, 5 square 25 and so on. Similarly, let's write D is equal to x dot to the power of 2, which says that I have to get the power of X matrix with the power of 2, which is element by element as there's a dot here. So 1 ka square will be 1, 2 square is 4 and 3 square is 9.